This video now is going to be kind of a precursor into the next topic we're going to talk about, current, which is moving charge. Well, this is electrostatics. It's charge that stays in one place, but I told you that we have to understand this first. So in order to get that charge to move, the first thing you have to do is build it up and hold it in one place. Okay, so we've talked about how to do that. Well, now how do we transfer the charge? To start to talk about transferring charge, we need to talk about conductors and insulators. A conductor is a material that allows charge to transfer or move from one object to another or from one molecule to another very, very easily. And you really need to know, this is very important, that the reason for this is that its outer electrons are held very loosely. We've already established that it's the electrons that are involved in electricity. Electrons moving from one atom to another, from one object to another, are the reason for charge transfer or charge buildup. And it's those outer electrons that really participate the most in electricity. So how tightly or loosely those are held determines how well that object or that material will conduct electricity. I told you that the electrons are held in the atom by the electrostatic force because they're attracted to the positive charges in the nucleus. Well, that force is going to be variable depending on how much positive charge is in the nucleus and how far away the electrons are from the nucleus. We've already talked about all that in the electrostatic equation. So you also need to know some examples of conductors, and those are things like metals and salt water, and most of you know that those things conduct electricity really well. Insulators, on the other hand, do not allow charge to move very easily. These are things that we use to prevent the flow of charge, and the reason they prevent the flow of charge is because, conversely, instead of holding the outer electrons very loosely, they hold them very tightly. Again, differences in the charge of the nucleus, the amount of protons in the nucleus, and differences in how close the electrons are to the nucleus. Those outer electrons, if they're held very tightly, they're not going to want to get rid of them, which means it's harder to transfer charge by moving electrons from one place to another. These are things like rubber, which everybody knows rubber is a good insulator. We use rubber for insulation on wires, as well as plastic and wood, also glass. Doesn't happen as much anymore, but more in the sort of old days, quote unquote, when electricity was first being developed, glass was used as a common insulator. Now, I want to take this opportunity to point out the fact that often in science, not just in this class, you are taught science by using these categories, and those categories are often taught to you as if they are discrete in nature, as it's either this or this. It's a binary system, so to speak. Well, you need to know that most of the time that we teach those categories to you, it's not actually that way in nature. It's not as if nature very nicely divides out into those two categories discretely. The reality is, with conductors and insulators in this case, there's kind of a spectrum of characteristics between the two. And some materials, like our metals and salt water, I put a pickle on here because a pickle will conduct electricity. There's a lot of salt water in it. They are good conductors, and they're on the far conductor end of this spectrum, whereas things like rubber and wood and glass, those are on the other end of the spectrum. But there are other materials that in the middle, sometimes they're good conductors, sometimes they're good insulators, or maybe they don't really do either very well at all. This also depends on how much charge is flowing and the current of that charge. For instance, we talk about wood. We listed wood as an insulator, but I think you probably all have seen that trees get struck by lightning before. Wood itself can serve as a pathway for electricity. Now, it's mostly the water in this tree that's helping it to conduct that electricity. But the point is, even these on this side, by calling them insulators, it doesn't mean that it's absolutely impossible for electricity to flow through them. It's really difficult, but under certain circumstances, it can happen. But there's a gradation, there's a spectrum in between these two, and some materials just kind of fall right in the middle between conductors and insulators. So you need to know what those are, and you need to know examples of them.